Hello everyone, hope all of you are doing great. And in today's video, we are going to discuss Unit 5, Paper 2 in the classified book. The first question over here is requesting from you to construct an inscribed regular hexagon. There is a specific video for this question, or actually for constructing any regular hexagons inscribed in a circle. There is a video that you're going to find in the notes, but for this question specifically, they are giving you vertex A. So if you remember, I taught you in order to construct a regular hexagon, you can start from anywhere on the circle, right? If you remember this. But right now they're giving you a specific vertex. So I should go over there and start exactly by putting the compasses on vertex A this way, and you open your compasses exactly the same size as the radius. So right now, I opened it exactly as the radius. Hopefully it is accurate enough. Okay. Now we draw an arc over here, and then I go to that arc and I stop there, and I draw another arc this way, and then I go to that arc, the point of intersection actually, and I draw another arc over here, and then you stop here, you put it on the point of, of intersection again, and you go down there to draw another arc, and then you go to this arc, the new arc that you've just drawn, until you reach 6 vertices. That is a big one because I lost sight of the rotation icon. And now you just to connect them. Or you can put also to make another arc over here. You can make it from the new one, or you can make it from this old one. Here you go. Another arc also over here. So now I got a list of the 6 vertices just to connect them, and this will give you the hexagon that they are requesting from the point of intersection, each point of intersection. Here you go. That's it. The arcs are, if they are shorter or a little bit longer, it doesn't really matter. The most important thing is that you show the arcs and don't erase them. What I've done right now is not erasing the arc. I just made it a little bit shorter. That's it. Okay, let's go to question 2. Here we go. Question 2. They're telling you that this is a pond, this is a scale drawing of a garden, and 1 centimeter represents 2 meters. 1 centimeter represents 2 meters. So there is a circular pond in the garden. By measuring, find the diameter of the pond in real life. So you're gonna find once you measure the diameter, which means with your ruler, you measure the whole line passing through the center with your ruler. You're gonna find that it is around 3.5 centimeters. Okay, mister, they said that 1 centimeter represents 2 meters. So multiplying this by 2, because they said 1 centimeter is 2. So multiplying this by 2, then you're going to have to write 3.5 multiplied by 2 equals 7 centimeters. And if you have a different measurement, anything between 6.2 centimeters till 7.2 centimeters is accepted. If you go to the mark scheme, here you go, you're going to find saying to you anything in between 6.2 and 7.2 meters inclusive, which means 6.2 is included and 7.2 included as well. Okay, let's continue. The owners want to build a shed in the garden. The shed measures 3 meters by 4 meters. 3, that means what? They said 1 centimeter represents 2 meters. But 3 meters is actually 1.5 centimeters, and 4 meters is actually 2 centimeters because they said 1 centimeter is 2 meters. So 2 centimeters are the 4 meters that they want. 1.5 centimeters are going to give you the 3 meters that they want. So you need to draw a rectangle, okay? A rectangle that is 1.5 by 2 centimeters. So you go up there and you draw a rectangular shed that is 1.5 by 2. So I cannot open the ruler in this question here. So, but I'm gonna just show you what you're supposed to do. Let's assume that this is 1.5 centimeters. And over here, you need 2 centimeters. That is going to be a little bit longer. It might look like a square, but it should not actually be a square because one of them is going to be 1.5 centimeters. The other is going to be 2 centimeters. Definitely, this is not drawn to scale. It's not accurate, but you should draw a line over here that is 1.5, a line over here that is 2 centimeters, and then you connect them. This is the shed that they want from you, 3 meters by 4 meters with a drawing scale. 1 centimeter represents 2 meters. So now 1.5, which is 3, 2 centimeters, which is actually 4. Find angle BAC. Okay, not a problem. I know that this is 90 because it's a square. And they told you that this is a regular what? One, two, three, four, five, six. So it's a regular hexagon. Following the rule n minus 2, you multiply by 180 over n will give you one single angle, one interior angle. So you will know that this is 120 degrees. So removing the n with 6 because this is a hexagon. 6 minus 2 times 180 over 6. With your calculator, you will find that it is 120 degrees. Now I can easily find this. How, Mister? 360 minus 120 plus 90. So 360 minus 210 equals 150 degrees. So this is 150. Write down the length of the hypotenuse of triangle BCE. Triangle BCE. Okay, they want this triangle that is in the middle. The triangle that is in the middle. The hypotenuse, semester, is the length of the side that is opposite to the right angle. We learned this. The opposite side to the right angle. So which is how many centimeters? Which is 13 centimeters. No calculations? No calculations. It is just 13 centimeters. All right, let's continue. Measure angle ABC. ABC. That's with your what? With your protractor. They said measure. So you need to get a protractor and you start measuring this. Ah, Mr. The lines are too small for and too short for my protractor. You can get your ruler with the ruler, okay? Not with your hand like me, with the ruler and extend the lines if you'd like to until they touch or until they become long enough. Just like that. Yes, just like that. Now you can measure this angle using a protractor. That's something that you learned in year 5 and we practiced it so many times in year 5, year 6, year 7. So you measure with the protractor. Normally, you're going to find that it's 110 degrees, approximately 110 degrees, yes. Or type. Now, write down I said approximately, but it's no, it's accurately. So do not, it's not going to be accepted anything else. Okay. Write down the size of angle ABC, which is the same angle in the enlarged shape. So they're telling you it's enlarged by scale factor 3. Mister, we haven't taken the enlargement of this here yet. Yes, you haven't taken it yet, but you should know that if we enlarge this shape, if the angle gets bigger and bigger and bigger and bigger and bigger, not the angle, the length of the sides get bigger, Mister, the angle didn't move even a single inch, a single degree. It didn't move even a single degree amidst the angle. So it is also 110 degrees. Again, if an angle is a specific measurement, let's say 110 degrees, and this shape gets enlarged, even if it got enlarged to the double, the triple, the four times bigger, السايزز بتاعت الangles remain the same. Enlargement doesn't change angles. This is the conclusion. Enlargement doesn't change angles. It was 110, but after the enlargement, still 110. BC is 5 centimeters, the CD is 15, and AC is 6. So they want you to find the length of BD. BD, mister, there is no side here, BD. Yes, you just need to do what? You just need to put this way, just split the shape, connect to make BD this way. You will find that this is what? 3 centimeters. And this is what? 3 centimeters. Okay. Definitely we're not going to measure it, but this is a kite. So yes, this side is equal to this side. It's an isosceles triangle. So anyway, you're going to find that this is 3, this is 3. Okay, mister, they want BD. BD, I got here a 5. I got here a 3. And this is a right angled triangle. So use the Pythagoras. We use the Pythagoras in order to find the size of this. All right, this short one until here. This short one until here. Okay, so I use the Pythagoras. This, let's call it A. A squared equals C squared minus B squared. So A squared equals B squared. Where's C squared? C squared is 5, which is 5 squared. So 5 is squared, which is 25, minus 3 squared, which is 9. So A squared equals, you're going to find what? 16. So it is 4 centimeters. So yeah, Mister, we know now that this one is exactly 4 centimeters. Okay, but what about the rest? What about this one? We're going to do the same thing exactly. The same thing. So I have this is 15, and I know that this is 3. I can find this one. So I'm going to say also A squared equals C squared minus B squared. A squared equals, what is C squared? It is 15. 15 squared, mister. Okay, so 15 squared minus 3 squared. You're going to find what? You're going to find here that 15 squared, if you do it, you're going to find 15 times 15 equals 225. So A squared equals 225 minus 9. A squared equals is going to give you exactly 216. All right, so 216, the square root of 216, doing it on the calculator is going to lead you to 14.69, or you can just say 14.7. 14.7 centimeters. It's this one, 14.7. Now I have estimated the length of all BD. BD equals 4 plus 14.7, which is equal to 18.7 centimeters. If you go over there, let's see how they accepted the rounding over there. The rounding, 14.7 we said. It is question 6. 18.7, I'm sorry. 18.7 is over there. So 14.7 and 4. The final answer is 18.7 as we agreed. All right. Next question. It says to you that this is an isosceles triangle. So the different side is DB. So D and B are the different angles. So D are the equal angles, I mean. This is 25, so this is 25 degrees. Can I find a Mr. X? Yes, now we can find X. It's on a straight angle or a straight line. Angles on a straight line. So 180 minus 115 plus 25 equals 180 minus 140, which is 40 degrees. Now, they want to calculate the length of the hypotenuse. C squared equals 8.7 squared plus 12.5 squared. So, C equals the root of 8.7 squared plus 12.5 squared. Then you open your calculator and you do this. Square root of 8.7 squared plus 12.5 squared equals 15.22, and they did not request a specific rounding to a specific degree of accuracy. So we're gonna look at the question. It is one decimal place, so we're gonna round it to one decimal place. It's 15.2. Here in this question, question 9, the diagram shows two parallel lines and the two transversals. Draw a ring around all the angles that must be equal to 70 degrees. So you're going to find that this is 70. Definitely the A is also 70 because they are vertically opposite angles. And you're going to find also that this is 70 because alternate interior angles. Look at this, making the Z letter. Look at that. Z shape. So 70 and 70 as well. Since this is 70, so D is also 70 because alternate interior angles. So right now, or actually you're going to find that D is corresponding with the 70 degrees as well. Angle D is also corresponding, making it the F letter. You see that? So if I erase this one over here, you're going to find that they are vertically opposite. They are corresponding. Look at the F shape. This is 70, so this is 70. This is 70, so also A is 70, vertically opposite, while the other is corresponding. So it is A and D. Let's continue. Draw a ring around the two angles that add up to 180 degrees. You're going to find angle C and angle B. Why, mister? Because interior angle of a regular pentagon and exterior angle of a regular pentagon, both of them, mister, we learned before that interior plus exterior, both of them add up to 180 degrees. So it is B and C. Find the sum of the interior angles of a seven-sided polygon, n minus 2 emister times 180. This would give me the sum of the interior angles. But 7-side emister, you have 5 times, because 7 minus 2, which is 5, times 180, which is going to give you exactly 900 degrees. So 900 degrees. ABCD is a rectangle measuring 4 centimeters by 10.5 centimeters. They're telling you to calculate DE. They want DE, which is this one. This one. They want you to calculate it. But, Mister, I know that this is 10.5 centimeters. So, AB, all of this is also 10.5 centimeters. It's a rectangle. AB is equal to DC. All of this is 10.5, then all of this is also 10.5. Okay, how is this going to help us? So far, it's not helping us at all to find the DE. But if I find this, it will help me find AE, right? So let's find EB. How, yeah, mister, are we going to find EB? I'm going to find EB through this right-angled triangle using the Pythagoras theorem. So 1.6 and 6.5. But this one is the hypotenuse. So the other one is one of the two legs. I need to find BE. Okay, so let's find BE, mister. BE equals 6.5 squared, which is C squared, minus a squared, which is 1.6 squared. So BE equals, doing this on the calculator, 6.5. It's square rooted, by the way, don't forget. I always gonna forget about this. BE equals square root of 6.5 squared minus 1.6 squared equals 6.3. So this is 6.3 exactly centimeters. Knowing that all of this is 10.5, part of it is 6.3. So what is the rest? 10.5 minus 6.3 is going to give you exactly 4.2 centimeters. Okay, now we've got something that will help us get DE, a right-angled triangle, but this is the hypotenuse. So this is 6.3. All right, this is the hypotenuse. It's C squared. So it's C. So to find it, I'm going to say DE equals square root of A squared plus B squared, which is 4.2 squared plus 4 squared. I'm using the rule of the Pythagoras theorem. Okay, so DE equals, let's find it, square root of 4.2 squared plus 4 squared, which is 16, equals 5.8 exactly. So it is 5.8. That is DE. Draw a ring around the sum of the exterior angles of an equilateral triangle. مصر السم بتاعت exterior angles بتاعت any shape in the world is 360 degrees. Sum of the exterior angles of any shape is 360. All right, here they're telling you, tick to show if Mia is correct or not about what? About in 20 more cheese pizzas are sold than meat pizzas. طب how can we find about this, semester? Here I've got the cheese, which is 60 degrees, out of 360. So it is a Mr. 60 out of 360 because the whole circle is 360. That is what? That is cheese. And we've got she's comparing also meat pizzas. The meat is actually the gray, which is 40 degrees. So meat is 40 out of 360. So they are saying it to you, is this greater? Mia says 20 more cheese pizzas are sold than meat pizzas. Mister, I still don't know Aslan how many pizzas. It is not 60 and 40. It's not 60 pizzas. It is 60 degrees. That's why we said it's 60 out of 360. It is not 40 pizzas to say, oh, yes, 20 more pizzas than that. No, it is not like that. This is not 60 pizzas, and this is not 40 pizzas. This is 60 degrees, and this is 40 degrees. Now, how can I find, Mr. the number of pizzas? Now, I'm going to do this. It is 60 out of 360 multiplied by 324 pizzas. And this is 40 out of 360 multiplied by 324 pizzas. Now I can find el cheese, how many pizzas, will meat are how many pizzas. Let's do this. 60 over 360. You multiply them by 324 equals, this is 54, while the other one is 40 over 360 times 324, it's 36. So showing that cheese is only, you're going to find that it is only 18 more than meat. So the only trick here is cheese is not 60 pizzas, it is 60 degrees, which is out of 360, the whole circle. And the meat is not 40 pizzas, it is 40 degrees, which is out of 360 as well. You do 60 over 360, 40 over 360, multiply them by the total number of pizzas that got sold, which is 324 pizzas, they will give you the actual number, 54 and 36. So you must take that she is incorrect. Question 14. A polygon has seven sides. The sizes of the six largest interior angles, 855. Calculate the size of the smallest. Yeah, Mr. Seven sides. I'm going to do n minus 2 multiplied by 180. And I remove n and I write 7. You're going to find that it is going to be exactly 900 degrees. They told you that six of them, six of the angles add up to what? 855. So the seventh angle is going to be what? 900, mister? But minus 855 equals 45 degrees. 45 degrees. Rajiv bisects an angle. Here is his construction. Let's go to this question over here. There are arcs that are missing from his construction. Construct the missing arcs accurately on the diagram. If you remember how to bisect an angle, you must know how to do this. If you do not remember, if you did not study it, it is explained to you in a video that is given to you in the form of a QR code in the notes book. But anyway, you must open the compasses over here, exactly the same size as the arcs that are given to you. Now, if you test this, it is the same as this. طب how can a mystery draw the missing arcs? If you remember the steps, after we draw these two arcs, which Rajiv has already done, you go to one of the two arcs and you do like that. And you go to the other arc and you go like that. These are the missing arcs. The point of intersection has been connected with the vertex. That's why we must use the arcs that are given. It will help us find how far or how long should I open my compasses. All right, that's it.